Welcome to the introduction of Wavelength Division Multiplexing or WDM. In this video, we will explore how WDM works and its significance in modern fiber optic communication systems. Wavelength Division Multiplexing is a technology used to transmit multiple signals simultaneously over a single optical fiber by using different wavelengths or colors of light. This allows for increased data transmission capacity, making it highly efficient. Wavelength division multiplexing is an advanced fiber optic communication technology that plays a pivotal role in expanding the capacity of the fiber networks by allowing multiple signals to be transmitted simultaneously over a single fiber optic cable. This capability is crucial for handling the growing demand for bandwidth in modern communication networks such as internet, telecommunication, and data centers. The key concepts are wavelength. In fiber optical communication, light waves are used to transmit information. Each signal in WDM is assigned a specific wavelength or frequency which corresponds to a specific color of light. These different wavelengths are then multiplexed to travel together down a single fiber. This is the process of combining multiple signals into one medium. In wavelength division multiplexing, it refers to the use of different wavelengths to carry separate data streams over the same optical fiber. Demultiplexing, at the receiving end, the different wavelengths are separated back into individual signals using a device called demultiplexer. This allows the original data streams to be recovered without interference. Coarse wavelength division multiplexing or CWDM, it uses wider spacing between channels, typically around 20 nanometer apart. This wider spacing makes the system less precise in wavelength control and makes it easier to implement. CWDM typically supports up to 18 channels with different wavelengths. Since the wavelengths are far apart, CWDM does not require highly sophisticated or expensive equipment to maintain the precise control over wavelengths required in dense wavelength division multiplexing. CWDM operates over a broad wavelength range, typically from 1270 nanometer to 1610 nanometer. CWDM is used for short distance data transmission, typically in metropolitan area networks and campus networks where high capacity is not a primary concern. It is commonly used in enterprises that require moderate capacity at a lower cost, such as connecting different offices within a city. CWDM is less expensive because it uses simpler and less precise optical components. The wider wavelength spacing means that temperature control and precision lasers are not necessary, reducing costs. CWDM equipment typically runs cooler and requires less cooling infrastructure, saving energy. With fewer channels and less need for tight wavelength control, CWDM systems are easier and cheaper to design, install, and maintain. CWDM offers fewer channels, which limits its capacity compared to DWDM. This makes it unsuitable for environments requiring very high data throughput. CWDM is generally limited to shorter distances because its wider wavelength spacing increases the potential for signal degradation over long distances. Dense wavelength division multiplexing DWDM uses much narrower spacing between wavelengths, typically between 0.4 nanometer to 0.8 nanometer apart. This allows DWDM to support many more channels up to 160 or more within the same wavelength ranges CWDM. With much tighter control over wavelength spacing, DWDM can pack hundreds of channels into the same optical fiber, allowing for extremely high data transmission rates. DWDM systems typically operate in the C band 1525 nanometer to 1565 nanometer. Long distance communications DWDM is used such as national backbones, transcontinentals, and undersea cables where high data capacity and long distance transmissions are critical. It is also used in large scale data centers and cloud infrastructure to manage extremely high volumes of data transfer over vast distances. DWDM forms the core of telecommunication networks, ensuring efficient transmission of vast amounts of data between cities, countries, and continents. The advantages of DWDM are high bandwidth. DWDM offers a significantly higher data capacity than CWDM. It is supporting up to 160 channels or more. This makes it ideal for high capacity networks like internet backbones and data centers. DWDM systems are capable of transmitting data over much longer distances, up to thousands of kilometers without signal degradation, thanks to signal amplifiers like EDFAs that boost signal strength over long distances. DWDM networks can be easily upgraded to accommodate growing data demands by adding more wavelengths without the need of additional physical fiber. DWDM equipment is more expensive because it requires precise wavelength control, temperature stabilization, and complex components to manage the narrow wavelength spacing. The tighter channel spacing and more sophisticated hardware mean that DWDM systems consume more power and may require more robust cooling solutions to ensure equipments operate optimally. Because of the precision required in controlling the wavelengths, DWDM systems are more complex to install, configure, and maintain compared to the CWDM. Some of the applications of wavelength division multiplexing are telecommunication. WDM is widely used by the telecom companies to expand the capacity of their existing fiber networks without having to lay more fiber. It is also crucial for providing high-speed internet connections. In cloud computing data centers, WDM is used to handle massive amount of data being transmitted between servers and storage systems. DWDM is used in undersea cables to transmit vast amount of data over long distances with minimal signal loss, playing a crucial role in global internet infrastructure. WDM is used by cable companies to send TV, internet, and voice services over the same fiber. And finally, in enterprise networks, WDM use data transmission between geographically dispersed locations, providing high-speed, reliable communication for their operations. Thank you for watching.